Okay, Satya. So yeah, I'll start this interview of analog, especially we'll start with the introduction part. So can you
Okay.
introduce yourself that what you are doing in IIT and what you are looking for in these coming days and what is the preparation about this company's interview of the semiconductor?
Okay. Good evening, sir. Good evening, Morandal. I am Satya Sai Komana. I am second year MTech student from Instrumentation and Integrated Electronics, IIT Kharagpur. And today I'm going to share my experience and how I'm preparing for a analog or which companies I'm actually preferring. Uh, and let's see what we can do today more and more. Let's discuss with our sir and
Okay,
let's
okay. So can
okay.
you tell something about what you are doing in MTech there, means project especially? Can you mention about that?
Okay, actually, I'm working on fractional and phasor local loop, which is very very important block in every aspect. Wherever you have a clock, you need the PLL, the two especially fractional and PLL. So it's a very very important block that I'm working. It's very good one actually.
Okay, so what do you mean by fractional n? Is there anything, something integral n type of something?
Yeah,
Yeah.
actually, fractional and PLL means it can divide the frequencies by a fraction value. That means if you have a any frequency like 50 megahertz, it can it can give you the output 256 to 200, whatever the required frequency you need. It will give. Actually, why we need this? Because generally, the everywhere you need the clock, but the clock signal coming from generally from nature, you will get from crystal oscillator, but it is
Okay.
very less amount which is present in our world. And the two, the crystal oscillator will generate very very less amount of frequency like 48 megahertz or 26 megahertz or something
Okay.
like that. But if you want the fast and fast transmissions, your signal frequency should be gigahertz level, 3 gigahertz or 9 gigahertz, 256 megahertz, and so on. So if you want high speed, you need high frequency, but that is not possible with crystal oscillator frequencies. But what we will do here is we will take the crystal oscillator frequencies and we will multiply with some integer or fractional value, and we will generate a high gigahertz or megahertz frequencies. But the system should be in a feedback loop. So we will create a one feedback the system in a negative feedback system so that it can operate very properly.
Okay. So you told you are working on the part of the PLL. So can you tell where this part is particularly used in the PLL structure? With this, with drawing the diagram, can you tell where your part is fitting in this complete entire structure of PLL?
Actually, I'm developing full fractional parallel except VCO, because I will show you the complete structure of the PLL so that I can tell you which block exactly I am doing, which or not.
Okay.
Actually, it contains uh, mainly four blocks. One is phase frequency detector and called loop filter or low pass filter. You can say anything. Generally, outer world calls loop filter, and we need a one VCO which can generate the frequency, whatever frequency you want, that is generated by VCO. And this is input frequency coming from crystal oscillator, input frequency. This is output frequency, which is our required value, which is in megahertz or gigahertz. But in order to operate the system in negative feedback loop, and as well as in order to get the multiplication of frequency, whatever you need, you can use this here. This is called general PLL block diagram. If M is integer value, that is called integer PLL, or if N is fractional value, then that is called fractional PLL. In outer world, this is very highly useful. This is also useful. This, but not that much. But generally you need this PLL. Fractional PLL is very very must and should in every application of communications as well as any digital circuits. You need the clock frequency. So in my architecture, normally I am getting input frequency 48 megahertz from crystal oscillator, and I
Okay.
am generating output frequency of 256 megahertz.
Okay. 256
So
megahertz.
so in order to generate from 48 to 56, I need the fractional value of around 5.33.
Okay.
Uh, Actually, I am designing this block, and this block. Till now, I have designed. Um, oh, sorry, I forgot one block here.
Charge
Actually,
pump. Charge pump, no?
that is, yeah. That is the main block I have designed till now.
That I'm also looking for where the charge pump is. Without charge pump, PFD charge pump, this PLL loop is not
Actually,
properly working, no?
uh, yeah. This
Okay.
and this, except this,
Hmm.
I am designing all those things. This is
Okay.
designed by our one of our seniors, Supriya. That is a very very great design which can generate the frequency up to 3 gigahertz. That is very wide range VCO. It is
Yes, yes. Wide range. Okay.
very very wide range from 100 megahertz to 3 gigahertz wide, very very wide range VCO. You can use any fractional field at this type. This is like a universal VCO, you can say, from 100 megahertz to 3 gigahertz frequency. So till now I
Okay.
designed this charge pump, and as well as I have designed this. Um, I haven't say that I have designed the divider, but we need a one control signal to operate this divider. This is
Okay.
also this control signal is coming from one modulator called
Hmm.
digital delta sigma modulator.
Okay. So are you designing this
The,
also, digital device
this is also,
modulator?
yeah. Till now I have designed charge pump and digital delta sigma modulator. I have implemented a charge pump in transistor level and a digital delta sigma modulator in Verilog A modeling, which is structural A modeling. Almost it is in a transistor level only. There is a several reasons I have why I implemented Verilog A model. Because I want to compare with other PLLs that therefore are in terms of phase noise characteristics. So that's why I need Verilog A modeling. So
Okay.
that too I am designing in Verilog A structural modeling, because whatever the effect you will get in transistor level, in Verilog A structural model also you can those effects will come into the picture, and as well as you can simply replicate that structural model into transistor level without any modification. I can say zero modifications. Whatever the structure you have in Verilog A, directly you can replicate in transistor level pin to pin
Okay.
without any things. So that is a very good block actually. Till now I have designed DDSM. If I want
Hmm.
transistor level, I can replicate that in one day. That I
Okay. So
can
you
say.
have designed it in very low gate till now.
Very log here. So if I want in transistor level, I can easily replicate in
Yes, yes, it
transistor level
can. Yeah,
within
it
one day.
can be replicated. It can be replicated.
Uh,
Okay, so what are your specs in terms of phase noise and other specs of entire design? And is there any challenge that you are facing in meeting any of the specs?
Actually, my main target is 250. I didn't get the any particular specifications of phase noise,
Okay.
because that you can't determine mine.
Hmm.
That you can't determine, that you can't target actually. That is
Hmm.
a little bit complicated one. How much phase noise you can generate it by a for particular input and particular output frequency. That whole things are dependent on each and every part of the PLL. Charge pump design, phase frequency design, loop filter design, VCO design, divider design. Every link is interlinked with phase noise. You
Yes,
cannot
yes,
predict
yes.
that.
Yeah.
But you can do one thing. After the design, you can interlink your design with your application. Then you can see whether it is your application is tolerated this phase noise or not. If it is not tolerated, then you can follow the optimization process.
Okay.
of this
So
phase noise
yeah, I
by
got the point. But till this spec meeting of 256 megahertz at the output frequency, what challenges you faced to get this particular frequency until the time you designed whatever the blocks you designed?
we actually the power consumption is also one of the matter. Actually, that is decided by charge pump.
Okay.
The whatever the charge pump I have designed is very advanced level architecture, which can reduce the systematic and random mismatches also, because that
Okay.
is very very useful. If the charge pump design is almost 50% of phase noise characteristics is decided by charge pump, or I can say, or 30% decided by charge pump, and another 50% decided by delta sigma modulator, and another 20% is decided by design. These three are very very important for your phase noise characteristics actually. So selecting a complicated structure for charge pump is one. I mean, I faced one issue actually, because
Hmm.
my charge pump specification output voltage is 0.5 to 1 volt,
Okay.
0.5 to 1 volt, and at the output side I have four transistors. At the output side I have below zero point 0.5 volt I have four transistors. Using this 500 millivolt I need to stabilize this four transistors, which is very very complicated
You
actually.
are
That
actually you are using a stack of four transistor within the
uh
500 millivolt range.
yeah, that is very complicated, little
Okay,
bit
so how
complicated.
much overdrive you are selecting for each of these stack transistor?
Actually, the last transistor which is connected to ground,
Hmm.
the overdrive required for this transistor is interlinked with op amp which is present in the charge pump actually.
Okay.
That too, because and this op amp has stack of two transistors,
Hmm.
which they like this is a zero point 0.5 is like a input common mode range, minimum input common mode range of op amp. Okay,
Okay. Hmm.
so around with 500 millivolt design is very complicated. If you have minimum common mode of zero point 0.5 for op amp, it is very complicated because your minimum VGS requirement is generally 500 millivolt,
VGS
right? But
requirement generally 500 millivolts for what kind of device it is?
because I am using 1.8 volt device, the two Mac device, um, UD 18 type. That means it's like a double well
So it is
type.
a
The
low VT device, I can say. Zero VT
It's
nearly.
not low. No. It's no, no. This is not low voltage.
Then how you are
No, it's
managing a
not a.
VGS of 500?
But now here question comes. Actually, I have incorporated two types of devices in the charge pump design. Actually,
Hmm.
so in order to achieve this, what I have in op amp for input transistor, I have used LVT device, which can consume
Can you
300 millivolt.
okay, right here, right here.
Okay, op amp have input transistor and tail node like this. Here I need here I need zero point 0.5 volt, zero point 0.5 volt minimum. But this
Okay.
device, if you take normal device, this device minimum conducts 600 millivolt to turn on this transistor.
Yeah.
So, but what I have did here is in place for this device, I have used LVT device. LVT
Hmm.
1.2
Hmm.
volt device.
Okay.
So in TT corner, it can consume only 300 millivolt. That is highly advantageous. So in
Okay.
worst corner only, it can go it can go maximum of 400 millivolt, because
Huh.
I have
That thing I
seen
asked you, that thing I asked you, you use something LVT there, low voltage device,
the
low VT device.
this is only these two in whole my charge pump design. These two only the elevators all
Because
are
these
one
are
point.
the input devices. Now, your input devices or op amp, we
Uh,
are giving the common mode of 0.5. It means they should be the LVT device.
Actually, initially I don't know that we can incorporate two type of devices in the
Yeah,
design.
in any
So
structure you can
after
how many type of devices you want according to your VT demand, VGS demand.
yeah, in order to, I took some time to find this. That too, according to the things I know, the elevated device is very costly. I need to ask my professor whether I can use my this costly device in my design is also or not. But here, this should be mandatory in order to achieve my specifications. So I should use this elevated device. I don't have any
Okay.
other option. So yeah, so I lost my cost constraint, but I achieved my thing.
Okay,
So
okay.
this is like this.
Okay, I got a lot of idea about your project. Is there any stability issue till now? Or you
Yeah,
think something about the stability?
yeah. In charge pump design, I have three loops actually.
Hmm.
The- I have used in charge pump only. I have used two op amps actually, two op amps, and that too in one op amp. There is two feedback loops, one positive feedback loop and one negative feedback loop. So I need to do the stability analysis for both of these loops and stability analysis for normal negative feedback stability analysis of another op amp. And
Okay.
my main target, and I mean, what I can say, I have put so much of time to weak the positive feedback loop also by using a compensating capacitor, I can say. So because anywhere, if you have both negative and positive feedback loop, that will create so much of issues. So you need to highly take care of that loop. So every time you need to check the both of the loop gains, uh,
Okay.
which are involved in both the positive feedback loops and negative feedback loops. So for every corner, that too I have simulated for more than 44 corners. So it's very complicated actually.
Okay, okay. Okay, then I got the point of it, means especially about the project. Now we should start with the basic questions of whatever I can ask about the RC or something else.
Okay,
Okay, so I'm just giving you the first question. I'll let you think it and solve. Okay, so there is an inductor of 1 Henry, diode with a cut-in voltage of 1 volt, is your 1 ohm.
okay,
Here I am giving the step voltage of 5 volt and I want the plot for V out. So, okay, solve
okay.
it.
Here or on my paper, I can.
Yeah, here only, here only. Yeah, I can scroll down. If you want a space, I can scroll down here and there.
Okay, okay,
Where you want a space, you can solve. You can draw your own diagram in the space if you want.
okay, okay. When I'm giving the step input,
Okay,
see this is at t equal to 0. I am getting very high frequency input, I can say.
okay,
Therefore, my inductor is open circuited. My inductor is open circuited, and my diode will be on. Therefore, at t equal to 0, my at V of 0 will be 4 volt. And because of the 1 volt across the inductor, that will that will develop a current through the inductor. What I can say, oh, at t equal to 0, whenever the diode on, the 1 volt come across this inductor. So this 1 volt will develop a current through the inductor I, right? So 1 volt. Yeah. So I think it is constant of 4 volt, maybe 4 volt. Inductor short.
Yes, take your time. You are thinking correctly initially. Just proceed with
Yeah.
that. Look at the
Okay.
diode, whether it will be off and when it will be off. Will it be off or not? Just look on the fundamentals.
Okay. You- So I think it's I need to draw the voltage across the inductor so that I can
Ah, you can
understand
draw.
more
You can
maybe.
draw whatever you want. You can do rough work you want to do. You can do, and
So
the
initially
same thing you
my
can do in your actual interview also. If you want some rough work, you can do.
okay, okay.
Hmm.
So initially I can say 1 volt, mm, 1 volt, 1 volt across the inductor. Uh, so inductor current is drawing. I think what can I say?
What are you missing? Where? What is the point of stuck? Where are you stuck? Actually?
Current across the inductor is constant. The current is continuously increasing or not? That's what my doubt actually. Uh,
So okay, okay. So
oh,
are
okay.
you getting any
Give me
clue?
one.
Are you getting any clue, or should I tell something?
No, give me a minute. Actually, initially here I have 4 volt. So some current. This will be drawn. No. Okay. I think I got the point. Yeah. Hmm. At starting, it is 4 volt. This is drawing some current. So initially current through this diode, but after inducting the developing some current, the current through the diode is decreasing actually. But the
Yes.
current
Now
through
you are on
inductor
right. Now
is
you are on right track. Yes. Yes.
yeah, but the current through the inductor is decreasing. Sorry,
Inductor is
yeah,
increasing.
current through inductor is increasing. So, but
Yes.
current through
Yes.
the diode is decreasing.
Okay.
But output side up to diode on the output side voltage across is 4 volt only.
Okay.
I can say up to
Okay.
T1, my
Hmm.
diode is on.
Okay.
Uh, Wait a minute, I will draw the current through the diode also. Initially, its current is 4 amps because 4 by 1 ohm. So same current will pass through the diode.
Okay.
So let me erase this thing.
Should I erase?
Okay, wait, I will erase. Hmm. Now similarly, initially my inductor current through inductor is 0, but it's slowly increasing and reaches 4 by 4 amps. In that meantime, my current through diode is 0. Whenever the current through diode is 0, so my diode is off,
Mhm.
but my current through inductor is 4 amps. And the current through inductor is constant, constant by 4 amps. It reaches the steady state. So my
Are you missing something? What is the nature of this current in this duration? What is the nature of this curve? You overrated it. Is it some exponential or is it linear?
it's exponential.
Are you sure?
It's exponential because sum of this IL plus. So current through diode is exponential.
Current through diode is exponential. But what is the current through diode? Is it
It's
exponential? Who is deciding the
initially
current across the diode?
resist this 4 by 1. This is deciding actually.
So this is the constant current,
The
then how it is exponential?
the IL plus ID equal to constant current 4 amps.
Huh.
But my diode is exponential.
Diode exponential? Where is this 4 plus ID? Where is the ID? What is happening initially?
Initial current through diode is 4 amps only.
4 amps? Okay.
4 amps.
Okay.
So my inductor current coming into the picture then. Slowly it's trying to increasing.
So what is the nature of inductor current? What is the voltage across the inductor?
Initially it is 1 volt.
Initially, or it will remain up to some time. Till the
Up
diode is
it
on,
will
till the
on
diode is
it
in,
will
it will remain 1 volt now.
it will remain 1
So if
volt.
voltage across the inductor is constant,
Inductor
that is
is
1 volt, it means what should be the current of the inductor?
so it will be linearly increased. The current
The
through the
current will be
inductor is
linear.
so yeah. Current through the
If
inductor
current
is
through the
linear.
inductor is linear and output current 4 amp is constant,
Con
it means
so
that
diode
for
current is also
constant,
linear.
that diode current is also linear. That thing I want to make you aware of.
Yeah,
That
the
is
diode
also
current is
linear.
also that is also
Linear.
linear.
Uh, Diode is not following its own equation here because it is forced by two linear currents. So anyway, it has to be linear.
Yeah.
It is forced by some other components. So now what should be the nature of means output voltage?
Up to it is 4 volt only. When up to what is the up to diode on?
Hmm.
My output voltage is 4 volt. Up to T1 my diode is on. So current is increasing linearly and
Okay.
current through diode is decreasing linearly.
Okay.
My diode is off. Um Here 5. It's now normal. I can say normal RL circuit.
Okay. Then.
Now inductor short circuit here. The I think the output voltage will exponentially reach the 5 volt.
Okay.
and current through the inductor is also reaching 5 amps exponentially. After linear, it's reaching exponentially linearly 5 amps. And the inductor current up to diode on, it is 1 volt. Whenever diode is off, it is decreasing exponentially
Mhm.
to
Okay.
0. This is T1 where I am assuming my diode is off.
So I think now you got how to approach and what is the
Yeah,
thing and what you
yeah,
were missing initially.
yeah.
Okay. Actually, as
Okay.
soon as this, if I'm considering that 1 volt continuously applying on the inductor, it means the inductor is charging. Charging means there is a current developing linearly. At the
Hmm.
instant when this current will go slightly higher than the 4 ampere, it means what will happen? When the current will try to
When
reach slightly higher than 4 ampere, it means the output voltage will reach slightly above 4.
uh, yeah,
As soon as output voltage is trying to reach slightly above the 4 volt, it means this gap is reducing less than 1 volt.
the 1 volt.
If this is coming just less than 1 volt, this diode is off.
Yeah.
And now what is happening? This gap across this inductor is reducing. So means at now after every coming instant, our inductor voltage is reducing. So it means inductor
Yes.
current is slowly reducing. That's why it is following exponential nature. So output voltage is also following exponential nature after that. Because directly
Yes.
that current is multiplying with this R is directly voltage output voltage. Okay, so
Yes.
I think now you got the concept of this question. So let
Okay.
move to the second question. Okay. Okay. So I want transfer function. V in 1, V in 2. So I want the expression of transfer function.
Okay.
This
First I
node,
will.
yeah, this node has some capacitance that you can consider Cx.
Okay.
So can you write the expression for the transfer function?
I need to derive it directly
If you can write
or
directly, it's better. Or if you have something to calculate the poles and zeros, then you can calculate also.
no, no. I will try to find intuitively.
Yeah, I try to
Um,
find. Okay.
okay.
Hmm.
There is one pole at this node uh, because of the output resistance and the CL,
Okay,
whatever
so
the
write down
output
all the
resistance
poles and means zeros expression and then directly put into the transfer function.
function. Okay.
Hmm.
I'm assuming this has 4, 1, 2, 3, 4. 4
Okay.
transistors. So my
Hmm.
pole 1 can be R04 parallel R02 into CL. I'm taking this pole and another pole is at this location, that is nothing but approximately minus 1 by GM3 into CX. And because there is a signal inversion from here to here and as well as here to here, that means output node is the signal coming from to the output node is two ways actually, because if I apply signal like this here, if I apply signal like this here,
Hmm.
because of this I am getting signal like this, and because of this at output node I'm also getting signal like this. So from input to output, I have two ways, but both signals are in same phase. Therefore, I can expect left hand 0. And
Can you calculate that zero expression?
this there is how can assume output. Mm, because of the signal, if I am assuming GM V in.
Satya, I am sending you the link again because this session is going to be over
Okay,
because there is a limitation of 40 minutes only on the Zoom in
okay,
one
okay,
time. So I am
okay, okay.
sending the